Esteemed Chief Guest, Professor S. Somnath, former Chairman ISRO and Advisor Space, Government of Andhra Pradesh. Guest of Honor, Professor Amitesh Umar, Head of Department, Space, Planetary and Astronomical Sciences and Engineering, IIT Kanpur. Honorable Chairperson, Sir Padampat Singhania Education Center, Srimati Manorama Govindhari Singhania. Respected Vice Chairman, Mr. Abhishek Singhania. Respected Vice Chairperson, Mrs. Varsha Singhania. Revered Vice Chairman and Director, Mr. Partho P. Kar. Respected Principal, Mrs. Bhavna Gupta. Distinguished faculty members, dear parents, and my lovely students. A very good morning to all of you. Sir Padampat Singhania Education Center has been a pioneer in skill-based learning, having integrated it into its curriculum even before the introduction of NEP 2020. This forward-looking initiative has significantly bridged the gap between K-12 education and higher studies, ensuring that students develop practical competencies along with academic knowledge. Strengthening the vision, SPSEC has established meaningful collaborations with prestigious institutions such as IIT Kanpur and Kanpur University. These partnerships contribute to enriching curriculum design, fostering innovation, and setting up of myriad labs that promote skill-based learning among our students. Through these efforts, Sir Padampat Singhania Education Center continues to empower learners with skills, confidence, and intellectual readiness for future academic and professional pathways. It is indeed a moment of great pride and inspiration for Sir Padampat Singhania Education Center as we gather here for an insightful interactive session with one of India's eminent space scientists, Professor S. Somnath, and to celebrate inauguration of the state-of-the-art Astronomy Lab. Today marks not merely the addition of another facility on campus, but the opening of a window to the universe, an opportunity for our learners to dream, explore, question, and innovate. The Astronomy Laboratory stands as a testament to this vision, offering students hands-on exposure to celestial observation, astrophysics concepts, and technological tools that nurture curiosity and critical thinking. It is our firm belief that such immersive learning experiences empower young minds to become creators of knowledge rather than mere recipients of information. Today's session is even more special because it brings our learners face to face with distinguished expert who has pushed the boundaries of human knowledge. His presence promises to ignite imagination, broaden horizons, and instill a deeper appreciation for the marvels of the cosmos. To formally begin today's program, I now invite the school captain, Arindam Naha, to extend the ceremonial welcome. Arindam.
Thank you, sir. Respected dignitaries, dear parents, and my fellow students, warm greetings to all. Today is a moment of immense pride as we gather for an extraordinary interactive session that celebrates curiosity, innovation, and India's remarkable strides in space exploration. With profound honor, I extend a warm and respectful welcome to our chief guest, Professor S. Somnath. Sir has served as a distinguished scientist, apex grade, Secretary of the Department of Space, Chairman of the Space Commission, and Chairman of ISRO from January 2022 to January 2025. He is currently the Vikram Sarabhai Distinguished Professor at ISRO and Advisor, Space, Government of Andhra Pradesh. Sir took his BTech in Mechanical Engineering from TKM College of Engineering, Kollam, with a university rank, Masters in Aerospace Engineering from Indian Institute of Science, Bangalore, with gold medal, and PhD from IITM Chennai. With a career spanning nearly 4 decades, Sir is a towering figure in space technology, particularly in the systems engineering of launch vehicles. His visionary leadership steered the national space policy, strengthened ISRO's collaboration with private space initiatives, empowered emerging startups, and enabled NSIL to undertake major commercial operations. Most notably, the historic Chandrayaan-3 soft landing near the moon's south pole, an achievement that brought global admiration, was accomplished under his inspiring leadership. Sir, it is a privilege to have you with us today. We welcome you, sir. I am equally honored to welcome our guest of honor, Professor Amitesh Omar from the Department of Space, Planetary and Astronomical Sciences and Engineering, IIT Kanpur. His profound research in galaxy astrophysics and his expertise in radio and optical astronomy instrumentation continue to shape young scientific minds and expand our understanding of the universe. We are grateful for your presence, sir. With deep respect, I also extend a warm welcome to our chairperson, ma'am, Srimati Manorma Govind Hari Singhania, whose visionary guidance continues to shape the school's progressive educational ethos. We welcome you, ma'am. A heartfelt welcome to our Vice Chairman, Sir, Mr. Abhishek Singhania, who is a source of inspiration and imagination behind our prestigious school. We welcome you, sir. It is an honor to have amidst us our Vice Chairperson, ma'am, Mrs. Varsha Singhania, whose constant support strengthens every initiative of our institution. We welcome you, ma'am. I also feel privileged to welcome our Vice Chairman and Director, Sir Mr. Partho Pikar, whose leadership continues to inspire excellence at SPSCC. We welcome you, sir. As we step into this enlightening session, may today ignite new dreams, spark scientific curiosity, and inspire every young learner to aim higher, just as India's space missions have done for the world. Thank you and welcome once again to this remarkable occasion.
Thank you very much, Arindam. Now I request our revered Chairman, Mr. Abhishek Singhania, our school's guiding luminary, to address the gathering.
Good morning. I am proud to welcome our distinguished chief guest, Dr. S. Somnath, former chairman ISRO and chief space advisor, government of Andhra Pradesh. Professor Amitesh Omar, head of department, space, planetary, astronomical sciences and engineering, IIT Kanpur. Respected faculty members, parents and students. Today is a very special day at our institute, and I say this not because I'm a trustee or a member of the management, but as someone who truly believes in the power of young minds. Dr. Somnath, it's a great honor to have you with us today. Your presence here has already created a lot of excitement, curiosity, and endless questions among the students. And this itself tells us why you matter so deeply to the next generation. A short while ago, I saw you interacting with the students in our robotics lab. What struck me most was not just the questions they asked, but the confidence with which they asked them. For many of these children, today will be a moment they remember, not for the rest of their lives, but because they spoke to a scientist who helped India touch the moon, their inspiration and their motivation. Dr. Somnath, under your leadership, India has achieved historic Chandrayaan-3 landing on the moon's south pole. But more than that technological achievement, what you've given India is a self-belief, a belief that, excuse me, a belief that with learning, discipline and perseverance, no dream is unfulfilled. Today, as we inaugurate the Astronomical Lab, our institute, you are doing something far more meaningful than cutting a ribbon. You are opening their minds, the young minds, to imagine something which is not being heard, to challenge the status quo. This lab will not just teach the students about the stars and planets, it will teach them to question, to observe, and to dream beyond boundaries. I am very proud to state that the institute boasts of some prestigious alum fraternity globally, and your presence will motivate them and the students to pursue science and technology and contribute to the nation, especially for the self-reliance. At this institute, we are committed to nurturing not just academic excellence, but curiosity, creativity, and courage. Facilities like the robotics lab and the astronomical lab are steps towards that direction. These are inspiration, like the one Dr. Somnath brings today. This will truly sparkle the dreams of the students. Dr. Somnath, on behalf of the entire SPSC community, students, teachers, and parents, thank you for taking time out to interact with our children and for inspiring them to look up at the sky with wonder and confidence. We are deeply grateful for your presence and look forward to a lot of new learnings from you. Thank you once again.
Thank you very much, sir. I now invite the guest of honor, Professor Amitesh Uma, to share his thoughts and inspire our audience with his vast experience in space and planetary sciences.
Yeah, all the learned people here, sitting here on the dais and there, all the parents, children. I'll share you with few things. When your principal ma'am, about a year ago, came to us and asked that can we do something in astronomy, my first reaction was let's think about it. And then she also asked me that we have a school and we want to start astronomy activity right from the lowest class, like the class 1 or something. Now that become a very challenging thing. How do you teach small children, that you look at something in the sky? Well, we made a pause at that moment, but then we had to think that yes, it's possible. I will share you a few stories in a very short stories that you might be already knowing, but then you can appreciate how important is this observational part, right? Not everybody can be, scientist or something, but very important that we do in our daily life is to observe something, right? When we look at the sky, and we do that from our childhood, right? We look at the moon, that's the first thing. और हम लोग फिर बहुत सारी लोरियाँ सुनाते हैं, right? That चंदा मामा दूर के and all that, right? We have to first get in the children that curiosity alive, that yes, the objects that we see, just the observation itself is very important. We don't have to delve into more understanding about this, that you can leave when the child grows and then chooses what has to be done later in the life. But these small curiosities, observational thing, we have to promote our children, I think, and right from the class 1 or whatever you say, even the child when they start seeing the sky. And I think in that direction, this astronomy lab which has been created in this school, and I'm very happy to see that within a short span of 1 year, this lab is ready, and it's very nice to see the progress made by the school in that direction. There are some books ready, some curriculum they are making that I understand. That's going to be very, very useful for the children. Engage them in all kinds of activity. You don't need a telescope. That's often we make a mistake, that astronomy is very expensive. We have to go to, you have to have a better telescope and all that. It's not actually required. The eyes we are fortunate to have, and you can actually see lots of things. And I will be very happy to see the curriculum includes activity which can be done at home, anywhere. You don't need expensive instrument. Of course, once you understand, then you can come back and do the expensive instruments and all that. But I'll be very happy to see that the curriculum will include all kinds of things which does not require great, instrument at home. With that, I would like to thank you again. That's a great initiative that this school has taken. Keep it up, I will say. Thank you.
Thank you, sir, for your encouragement and appreciation. Now, with great honor and immense pride, I invite Professor S. Somnath, former chairman of ISRO and a visionary architect of India's space journey, to address the gathering.
Good morning, all of you. So, are you ready with the questions? Okay, very good. So, my honor and respect to Srimati Manorama Govind Harisinghania ji and all the distinguished people on the dais, parents and teachers, really an honor to come to this school and watch the way you are preparing young minds for the future. I had an opportunity to go around the labs and then see the work that you are doing. Very happy to be part of the inauguration of the astronomy lab as well. I think this is something really good to happen in a school, to have such facilities for you people to tinker on and work pieces like robotics, space, astronomy, etc. And I'm really sure that this type of activities here in the schools will really kindle the mind of inquiry and understanding. I think that is what is needed for most of you. So I won't give you a big talk today. I will rather wait for your questions and possibly an interaction. I think that's what is better for you, all of us, right? Okay. But then before we start, I think it's something very interesting. I was there and looking through the telescope. I could see a mobile tower far away. No, not any stars or planets. No, I could see only a mobile tower. And it was very sharp and very clear. But I was wondering, recently America launched a spacecraft called James Webb. Heard of this? James Webb telescope. How many of you know about it? Yeah, I think many of you know about it. I think that telescope has a very big mirror which can collect light from far distant galaxies. You know how far distant? It's almost 13 billion years back. The light came from those places. You can collect the light, you can make an image, and then understand the universe. So basically the whole telescope or the spacecraft is built to look at deeper and deeper into the universe. When you say deeper and deeper, I get confused. Are you looking at the distance or are you looking in time? Time. Then when you look at times, you know the Big Bang occurred sometime many years back, something like 13.5 billion years back or so. I don't know exactly, maybe near to that. Sir will know. So 13.5 billion years back, the Big Bang occurred, and many million years back, the visible universe as we see here appeared. And now we are here with Earth, Sun, and planetary system, everything. And when you look deeper and deeper, are you seeing today or are you seeing yesterday? Now you look at far away. Are you seeing the sun of yesterday or are you seeing the sun of today? Or when you look far into the sky, are you seeing the stars of yesterday or are you seeing the stars of today? Yesterday, why you are telling stars only yesterday? You are about sun, you are telling today. Now let me tell you, have you really seen stars? In the night, are you getting out of your home and looking at the sky sometime? Yeah, I think you should look at the sky is still blue here a little bit. Not in cities, it's not this much blue. Possibly you are able to see some stars in the evening, night skies. Are you able to see stars? Okay, so when you really look at the stars, let me ask you a question. Are they really there or not there? Not there, you know it. I think you know it very well. Stars are really not there. Whatever you see are really not there. Then where are they? Long time ago. I think it is correct. I think all what you see are the pictures which was painted many, many years back. How many years back? Light years back. Hundreds of years back. Not 1 year back, yesterday, 1 month back. No. Those pictures, you know the closest star is Alpha Centauri. You know the Alpha Centauri? And you know how far away it is, Alpha Centauri? Almost 4 light years away. And you know, after that, there are stars which are 25 light years away, 100 light years away. That means the light from the star will take almost 100 years to travel and reach your eyes. Just imagine. So whatever stars you see on the sky are not the stars of today. They were stars of yesterday. 25 years back, 100 years back, whatever light started from that star is still traveling all across the universe and reaching your eyes at this moment. Just imagine what you see are not the picture painted now, they are the pictures painted hundreds of years back. That means if you really look deeper into the universe, you can actually see not distance, you can actually see time. Yeah, you can see deeper into the time. That's why James Webb telescope can actually see images of 13.5 billion years back, 13 plus billion years back. So just imagine, now today we have this meeting today, no? I have come to this school and all of us are watching this event. Let me ask you a question, can you see this event tomorrow? No, we will, after 1 hour or so, we will complete this event and we'll go home. After that, can you see it tomorrow? Yes, we can see, because he is taking a photograph and video, you can run it in your YouTube and see it. No, I'm not talking about that. You can actually come and see this tomorrow. If you come here and then look at this podium, will I be here still? The answer is, if you can see a star which existed 100 years back, you should be able to see me tomorrow at least. Is it correct or wrong? Yeah, you should be able to see, because you are actually seeing history today. When you look back into the universe, you are seeing stars which existed 100 years back. You are seeing a sun which existed 8 minutes back, because light from sun takes almost 8 minutes to come. Even if the sun explodes at this moment, you will not know about it. After 8 minutes only, you will still see the explosion. You will not see it now. So, if I am speaking here today, now after 1 year, if you want to see me, what will you do? Yeah, tell me. Not light years, I am talking about 1 year later.
Yes, sir. So,
you have to see me speaking here. What will you do?
sir, we'll go like far away from.
Not far away. I will go to a distance which is that light takes for 1 year to travel.
Yes.
At that point, if I look here and then look at a telescope, look at the school, you know, you will see me standing here and speaking, right?
Yes, sir. Because
Yeah, you
light
can see,
takes time
because the
to
light
travel.
from me is going out of the universe and it is traveling into the vast ocean of the space, and whoever goes there and look at me many years later still be able to see me.
Yes, sir.
Yes or no?
Yes, sir.
Yeah, so that is the beauty of it, that even if I am dead and gone after hundreds of years, the light from me is still traveling into the universe, and you will be able to see that, provided you are able to travel to that distance and look at me. Is it interesting?
Yes, sir.
Yeah, so that is a very interesting part of the universe. That is the beauty of the telescope. When you look through the telescope, what you are actually seeing is history. So you can actually see Gandhiji, the freedom struggle. Can you see the freedom struggle? Yeah, just travel 75 years back and stand at a distance which is the light takes for 75 years to travel, and look at India. You will be able to see freedom struggle going on. India getting independence. Our tricolor being raised in the Red Fort. All that you can actually see. Just imagine this. Is it interesting? Yeah, it is not a science fiction, it is reality. And this is how the universe is. The story of what you see on a daily basis can actually return in the history forever. Only problem is whether human beings can actually travel this far distances and then actually see that. This is a big issue. So let me come back to the James Webb Telescope. Now James Webb Telescope can actually see the universe deeper and deeper and then take pictures from 13.5 billion years back. And what actually he has seen by the James Webb Telescope and many other telescopes that humanity has launched. Tell me some telescope names. Hubble, yes. Then? Anyone, any other telescope? Chandra, heard of Chandra Observatory? Subramanian Chandrasekhar's name, there was a telescope launched by US and that is called a Chandra telescope. There is another telescope called Kepler. And India also launched a telescope. Anyone name that telescope? In space. Now, can anyone tell the name of the Indian spacecraft which had a telescope to look at the universe? Astrosat. Heard of Astrosat? I think you should search Astrosat and find out what Astrosat has been, and it is one of the beautiful satellites that we have launched. It is still working. It is able to look at universe, understand universe, black holes, and many, many other features. I think a lot of publications have come out of it. I understand almost hundreds, almost 400 publication has come out of that satellite alone. It's an India's contribution to astronomy. And this is very, very interesting to understand that you can also build, India can also build satellites like Hubble and Chandra and Kepler and James Webb, but not without spending that much of money, very small money. But unfortunate that you people are not knowing about it. I think this is something which I want to tell you. What India does must be known to you people. I think we are also building interesting instruments, interesting telescopes, interesting observatories to understand. Can anyone tell me the name of the satellite we launched recently to study black holes? Anyone? Heard of XPOSat? XPOSat? I think you should also write down in your notebook and then search and find out what is XPOSat and what XPOSat can do. It's an XPOSat is a satellite. When I was the chairman, we launched that satellite. It is meant to study black holes. I think all of us are interested in black holes, right? How many of you are interested in black holes? I think a lot of people are interested in black holes because most of you are wearing black color dress. Not because of black color is black hole unrelated. Black hole is a very beautiful concept. Still being studied in great detail. Put your hands down. I think our XPOSat was designed to study black holes. And when you know black holes, when you come very near to a star, what it does is, it will attract the star. It will take away the material from the star. And the material will move at tremendous velocities to the star. And that whole material will be eaten by the star, by the black hole, slowly, and it will get absorbed into the black hole. Black hole has a beautiful thing. If there is a small black hole here, slowly all of us will be eaten by the black hole, and black hole will grow big. And all that is around this will be eaten by the black hole. And such things happen in the universe at many places. And if you observe them, what will you see is this material which is coming from the star, when it is pulled by the black hole, it emits X-rays, very powerful X-ray radiation. And you can actually measure the X-ray. And you measure the X-ray, you do some techniques. I don't tell all the techniques here because it is a little more scientific. You can find out how much material is being pulled and how much of the stars are getting eaten into by the black hole. And you can do this measurement. And the whole satellite called XPOSat is designed to study this effect. That is called accretion of materials by black holes, of pulling away materials from other bodies. So this is an interesting satellite that we have made and launched. So ISRO has lot of programs for astronomy. I think all of you, if you are interested to study, to become an astronomer, I think you should be going to this lab, looking at this telescope, trying to understand how the universe is getting created. You can look at history through the telescope. I think whenever you reach a telescope, just imagine you are actually seeing history. So your history teacher also should teach them that history can be seen through telescopes. Very good, no? Chandragupta Maurya, Akbar, Humayun, all you can see through the telescope. Interesting? Yeah, now let me slightly change my subject. I think it's equally important to understand. We also had a great tradition of looking at space, looking at planetary objects, looking at the creation of the universe. I think all of us should be aware of our tradition of India, especially the scientists that worked in India. They were rishis, they were observers. I think all of you know about Aryabhatta, Bhaskara, Varahamihira, Brahmagupta. Heard of them? Yeah, I think all of them did wonderful work in terms of understanding the structure of the universe. Not just writing stories, they were actually observing. I am coming from Kerala. I think my name, possibly my language and accent should be, no, you should be able to understand I am from Kerala. But Kerala had a tradition of observational astronomy. There is a school called, it's there in the poster there, it's called Madhava School of Mathematics. I think there is a poster there. You can read that. And that school of mathematics existed in Kerala. And what they used to do is they were astronomers. Every day morning, every day night, evening, they will come to this, there is a river there called Bharatapuzha. In the river bed, there is a rock. And this fellow will lie down with bare eyes every day in a one position. He will, fixed position, the rock is still there. And he will fix his eyes on the sky. And using the observed thing, he will mark it on some papyrus or something like that. And every day these changes are recorded by pure eye observation. And layers of such information was, no, you observe it over a period of time, years together, without missing a single day. And you can mark the movement of planets, you can mark the movement of stars, and then make calculations about planetary periods, the distance between moon and earth, how different star constellations are actually moving related to each other, and then make some conclusions out of it. And they were great mathematicians. I think it talks about even early calculus came out of their observations. The numerical systems came out of their observations. And one of the very flourishing mathematical traditions of our country came from those people who are called School of Mathavas. I think you should study about it. And equally interesting is something which I read recently. There was an interesting book released by one of my professors in the Indian Institute of Science. His name is Iyengar, and he is a Sanskrit scholar. And he did research on a lot of books in Sanskrit and found out that Indian scientists actually discovered very well the many equations that Newton and many Einstein and many others actually explained in mathematics much later. For example, the gravity, the time, the concept of time and its explanation, the elongation of time, the relativity to a little extent, the gravity to a certain extent. Similarly, the planetary motion, which you have the sun-centric, the solar system. You know, human beings believed that the whole universe is centered around Earth once. You remember that it was the story long back. And to people to realize that the sun is the center of the solar system, it took many years for them to understand. But Indian scientists understood it many years back, much before that the West understood. I think this is an important tradition. I think all of us are the descendants of that tradition. We were all the descendants of that great scientist of our nation. I think we should be proud about it. I also want to tell you that we have a new generation of scientists as represented by Sir here. At IIT Kanpur, they are starting a department of astronomy and space. I think this is something really great. And Sir is also from an institution called ARIES, where actually we have observational capabilities, we have telescopes, and we also do fantastic science with respect to Moon, Mars, and many other planetary bodies. That's why we have missions like Aditya L1. How many of you know about Aditya L1? Yeah, I think all of you know about Aditya L1. I am very happy about it. And what is L1? There is one more L5 also. Okay, what is L? What is L? It's a Lagrangian point. It's called Lagrangian point. It's a point where the gravity between two bodies, when you have two bodies, sun or earth, or moon or earth, you can create points where the gravity becomes neutral. The pull between these two will become neutral, and there are different points. Some of them are called stable Lagrangian points, some are called unstable Lagrangian points. And L1 is a point where you can actually put a satellite. It will not either go to moon or go to earth, or go to sun or to earth. So we have put it L1, which is the L1 between sun and earth, to look at earth. And what is the advantage? If you put something at L1, what is the advantage? Anyone? It will not either go to sun, it will not come back to earth also. It will stay there. But advantage is it will look at sun without any obstruction. There will be no obstruction from moon or earth or any other body when you look at sun. It always looks at sun. And another advantage is it always looks at earth also. So you can look at earth, sun, take images and send data to earth without any obstruction. And that's the beauty of L1 point. And that's why we took, where is L1 point? Anyone tell me how far away is L1 point? Yeah, you want to tell? How far away is L1 point? It is almost 3 times the distance of moon from earth. So it is so far away. It is almost 12 lakh kilometers away from here. It took almost 6 months for us to travel and reach there. And so precisely you have to reach. If you miss it, you will not come back to that L1 point. So it was wonderful mission for very, very strong calculation of mathematics to reach there and very precise control system to reach there. I think ISRO did a wonderful job. Congratulate all the great scientists who actually built the mission as well as instruments. Today we have wonderful data from the Aditya L1. And all of us know about Chandrayaan 3. How many of you watched the Chandrayaan 3 landing? Oh, there are still people who did not watch. I wanted everyone to raise the hand, but none of you, many people have not raised their hands. So I will tell you, you should go and watch the video now. It is there in the YouTube. Okay? All of us should watch that video, Chandrayaan 3 landing. It's a very proud moment for all of us. Our Prime Minister is joining in that, seeing and watching it live, you can see. And all of you know that the first attempt we did not make it very well. No, Chandrayaan 2, about the last point we had a problem. It actually crash landed and we couldn't get the data. So we understood what went wrong, did all the corrections, and it took almost 4 years for us to correct and come back and land. So, but once after landing, we were very happy to see the rover coming out. Beautifully it came out, it did all the experiments, and we have a lot of scientific data today. And you can get all the data. Once you grow to become scientist, you can actually get all the data. And it's a public data. And this is something which I want to tell you young people who are interested to become scientists. Whatever we did on the moon, the images, the data, the scientific outcome, everything is publicly available. If you are interested, you can register with your email and get the data to do a scientific study of the moon. You can publish a paper. I think the school should take an action. How to take this data? One publication from the school should come on moon from this data. And any teacher who are an interest to do this, you can actually do that. And ISRO will help you how to do a research on moon using the data from Chandrayaan 3. You should do that. Okay? Okay, let me stop here and then wait for your questions. I think if you have any specific questions and area that I should discuss with you, I will be very happy to do that. So I will give more time to you instead of me speaking. Right? Agreed? So who are all ready with the questions?
All right. Good afternoon, sir. My name is Ananya Tiwari. Sir, I'm studying in 9th standard. I really wanted to ask you this question. What inspired your fervent passion for aerospace engineering, and how did you realize that you wanted to take aerospace engineering as your career?
My dear, it all started with my father. No, he was a very passionate sky observer, I must tell you. When I was a student, when I was young like you, he used to bring a book called Star Atlas to my home. Now, the Star Atlas is actually for month of January. This is how the sky is. You can still see this in some English newspapers. It comes. Hindu, for example, they publish monthly the Star Atlases. So, he will bring the Star Atlas, and night time we used to sit outside the home and look at the sky. And he will tell me this is Uttara Bhadra and this is Maka. And then you can identify the star constellations, which you call your birth star. Now, what is your birth star?
Sir, I'm not aware of it.
You don't know your birth star? You heard about birth stars? Yeah, we all have, no, our Jyotisha people talk about birth stars. Okay, not the Aquarius or the English style. No, I am talking about the Indian stars. 27 stars are there in which we are born. So, the star we are born are the stars on the day where the sun rises in the star constellation is called the star of ours. Do you know that? In the sky, there are 27 star constellations which we identified.
Yes,
And
sir.
on that day, you are born. At that time, at that day, whatever star is there, along with the sun which rises, is called the star of yours. And this is a scientific thing. It is non-scientific. So I used to observe this along with my father, and it was very interesting for him to explain this to me. So when I grew up, I was very fascinated. Then two books came to my house. He brought these two books. And one of the book is called Einstein and the Universe. It was a very small book. It talked about Dr. Albert Einstein and his work on the theory of relativity. And that I read at the age of maybe 12, 13. Very simple book. It's not a complex book to understand. And another book which I read was The Captives of the Sun. And this was not in your time, it was 1970s. You just imagine, 1970s I read this book. And this book was about sun and the planetary system. And about the Voyager, which Voyager went beyond the, now beyond the solar system you are aware of. That Voyager just took some early pictures at that time, and that was there in that book. So I was really fascinated to read that book. And then when I grew up, I decided that I will be very much keen on science and science. But I didn't know much about engineering. At that time, there was no much knowledge about engineering, and joining ISRO, nothing was known because SLV-3 was not even launched. Abdul Kalam was still making the SLV-3, which is yet 1980 only he did. But by the time I finished my schooling. So after that, I went into engineering, and then I realized, after joining engineering only, I realized where ISRO is, what I can do in space. So after joining engineering, I decided I am going to join ISRO. So then I did, even my college didn't have space related subjects at that time. So I went to a professor, I said, I want to study space and rocket science. And that professor said, I also don't know. I will learn and teach you. And in the engineering college, he taught us propulsion, rocket propulsion at that time. And that helped me to get a job in ISRO. And after joining ISRO, then I realized what my dream is and where I should work, etc. So it all came naturally because of the interest in the family. You parents, I think you people have the power to change their destiny by doing something like this. Okay? Thank you.
Thank you, sir. Thank you, sir.
Hello. Pleasant greetings, sir. I'm Agrima Patel from class 7th. I'm pondering that how...
Go ahead. Don't worry, don't get distracted.
I'm thinking that what are suggestions you will suggest her for the skills that we must have to work in challenging field like aerospace?
Oh, aerospace is such an interesting field that you don't have to study anything very deeper. Very simple. Are you interested in aerospace? Are you? Then I will tell you the secret. First thing is, you don't study anything very deeper and become very complicated. Aerospace is such a simple subject. Every subject you need to learn little bit. Then you become an aerospace engineer. You understood what I mean? So aerospace engineering contains all the subjects that you can talk about. It contains material science, aerodynamics, control, electronics, chemical, propulsion, mechanical engineering, civil engineering, electrical engineering, all of them little bit, and then you become an aerospace engineer. So the technique of becoming an aerospace engineer is, none of these are important. You need to have a passion, you have an interest. So what do you like most?
Science?
No, in the science, what do you like most?
Geography.
Geography, okay. In geography, what do you like most?
I like space,
Geography is not
planets.
space. Planets. So it's more of geology of planets. Yeah. Okay, how they are built, what material it is used to build. Okay, where elements came from, something like that, no? Origin of these planets, geology of these planets. Are you interested? Or how water came on earth. Interesting? And you know one interesting story? Are you the product of stars? Do you know that? Your body is built by stardust. Do you know this story? No. I'll tell you this story, very interesting story. I think have you studying chemistry in school? You know
Not right now.
periodic table?
No.
Periodic table, do you know?
We have not studied right now.
Right now, okay. There is some, whoever knows periodic table? A lot of people know periodic table. You know elements, hydrogen, helium, beryllium, carbon, nitrogen, oxygen, different elements, no? So the universe or the earth is made of many, many elements. Hydrogen, oxygen, carbon, silicon, iron, copper, cobalt, uranium. There are so many elements here, right? And all these elements in this world came from where? How all these elements are there on earth? Why? There is something is missing here. But most of the elements that you know in periodic table are here only. Some who are not here are unstable. They cannot be produced. But most of the elements you can find on earth. So why is it so? Anyone knows? The secret is that the earth is created out of elements that came from stars. So we are a product of stars. So originally when the universe was created, there was only stars. There were no planets. And the stars contained only one element called hydrogen. And when the hydrogen fully burns, it becomes helium. And when helium completely burns, it becomes the next element. Which is that next element? Sorry, sir knows sometimes. So hydrogen burns to helium, helium burns to carbon, then to iron, and then to different elements it can create over a period of time. And once it reaches a critical condition or mass, it explodes and creates higher number of elements. Like all the high molecular number elements are created out of the explosion of the stars called supernova. So when the universe is created, stars came first and elements were created by the explosion of the stars. And these are created only in very fraction of a second. Hydrogen to helium conversion takes millions of years, sometimes billions of years. Helium to carbon takes millions of years. Carbon to iron takes few years. And iron to higher elements happens in seconds. So this process is what actually created all the elements of the universe. And these elements are thrown out into the universe as dust. So they are dusts of exploding stars. And all these dust came together coagulating to form planets like Earth. And you came out of Earth. So all what you see here are results from the explosion of stars of the universe. So over billions of years, stars were being created, exploding, throwing out dust, and all this dust across the universe coagulated to create the planets like Earth, Moon, Venus, Mars, everything. And millions of planets across the world were created by same process. So just imagine that the hydrogen and carbon in your body was once in a star, not the sun. Some other star which actually existed, exploded and died. And that dust is what makes all of us. Do you understand that? So it's an interesting thought, to know that all of us are the product of a star which exploded one day. And the water which you drink are the water which existed billions of years back. Still, sometimes a dinosaur would have drank that water and you are still drinking the same water. It doesn't go away, it still gets recycled, over a period of time. You are simply recycled and recycled and recycled. It's an interesting topic now. So that is something related to geology of the subject of what you are interested in. So if you want to become an aerospace engineer, the only technique is wonder about the universe. No, you think about these type of things. You will naturally become a scientist. You will become a aerospace engineer. Okay, you don't have to study anything else. Very simple. Just observe the universe. Just get wondered about all that is happening. Read very well. Read some good books. You will guide it to the right path. Okay. Thank you.
Warm greetings, sir. I am Rajan Riju from grade 11th. It's truly an honor to meet you, sir. Sir, you have been an integral part of ISRO for so long. Would you be able to share the developments that India would make in space programs in the next decade or so?
So you want me to tell you about the future?
Yes, sir.
Okay. The future, because I was there as the Secretary of the Department of Space and Chairman till 25 January. So I can tell you that the vision for next 25 years has already been written. One of the interesting things that happened after the Chandrayaan-3 landing, I think all of us know that the nation celebrated it very well. I think the work done by Department of Space and ISRO has been really hailed as one of the very, very interesting story. And we need a vision for next 25 years. And the government was very keen to bring out a vision. So I will share that with you. So one of the important things that we said that in the next 25 years, we must scale our space activity substantially. Today, we spend very less money on it. No, we spend almost 12,000 crores per annum. It's not a huge money. So we decided, and our contribution to the economy of the space is very small. As far as global economy is concerned, which is valued at around 500 billion USD, our contribution is only 2%. Just 2%. For a nation like India, we should have contributed much bigger. So we decided as a government that we should increase the share of our economic contribution to something like 10% of the 500 billion. Maybe after 5 years, the 500 billion may grow to maybe 600, 700, 800 billion. So at least 10% of that we should own. And for that, we need a lot of private entrepreneurs to come in. And this is one decision we have taken. And we have opened the space sector to private. And this is important vision change that we have happened. Earlier, only ISRO was working. Now, a lot of private companies are working in space. And I know JK Group is also contributing very well towards it. And they are also into space activity and aerospace activity. It's very interesting to see that. The second point I said, where we decided that we have to invest more from government also in space sector. So we made a long-term plan for next 25 years. We should land an Indian on the moon by 2040. Before we celebrate our 100th year of independence, we should have an Indian standing on the moon. This is another decision that we have taken. And we should build our own Indian space station called Bharati Antarisha Station, and that target is 2035. So we should go to space, build our space station, send our Indians to space on a continuous basis. We should do microgravity experiments and other related science in space. We should go to moon again, not the sending the man, but before that itself we should do many more moon missions. And we should go to other planets, for example, Mars and Venus. 2 projects are already approved to land on the Mars. We sent a spacecraft which is orbiting Mars, so we are now going to land on Mars. And also we are going to send a probe to Venus, which is a very interesting planet. If you are interested, we will discuss it later. So we are also going to increase the number of satellites. Today, India has only 55 satellites. And we are going to triple it or even quadruple it in the coming days. More satellites are going to be launched. Possibly your mobile phones will be served directly from satellites. Today, mobile phone signal comes from where, From the towers. Mobile towers are the one who transmit signals. And in very short time, I think signals will come directly from satellite to your mobile phones. You don't need another antenna or sometimes. So technology is changing and satellites are observing what is happening today. They can take images of each and every individual moving on the road to some high clarity. And it will become part of our IoT ecosystem, our climate and weather, our disaster warning, our resource mapping. So many satellites are going to be launched to do that. So there is a large-scale plan of investment and technology intervention, especially in the domains of quantum, IoT, AI. All we have made a big roadmap for space already, including reusable rockets, space debris-related activities, space debris removal, because space debris is a major issue. So we have made programs for it. Like that, there are a series of programs that we have built for ISRO and for the country. Good enough? Okay.
Honorable Sir, I wish we had some more time to quench the thirst of our curiosity seekers, but really we are at a time crunch. Thank you so much, sir.
Thank you.
Ladies and gentlemen, let's express our heartfelt gratitude for the precious time and brilliant insights shared with us today. Please join me in giving Professor S. Somnath a thunderous round of applause for illuminating our minds and inspiring our young dreamers today. Sir, I must tell one thing, that in 2023, when the soft landing of Chandrayaan happened, our school also celebrated it in our annual function. It was recreated almost, and everyone enjoyed it. It was in 2023. So after India celebrated, we continued with the celebration of this in our annual function, sir. So thank you so much. Now, I would invite our esteemed principal, Mrs. Bhavna Gupta, to deliver the vote of thanks.
Respected Chief Guest, Professor Somnath, Guest of Honor, Dr. Amitesh Omarji, Revered Chairperson, Srimati Manorama Govind Hariji Singhania, Esteemed Vice Chairman, Shri Abhishekji Singhania, Vice Chairperson, Ma'am, Srimati Varsha Singhania ji, Vice Chairman and Director, Mr. Partho Pikar, distinguished members of the JK organization, eminent guests, esteemed parents, faculty, students, and members of the press. Good afternoon. On behalf of Sir Padampat Singhania Education Center, it is both my privilege and honor to deliver the vote of thanks on this significant occasion, marking the inauguration of our astronomy lab, an important addition to our institution's academic and scientific landscape. We are deeply honored by the presence of our chief guest, Professor Somnath, whose exceptional leadership in India's space program has elevated the nation's global standing. Sir, your stewardship of landmark missions and critical advancements in India's human spaceflight architecture represents scientific excellence at its height. Your address today has profoundly enriched this gathering and will inspire the students and faculty for years to come. I extend our sincere gratitude to our guest of honor, Dr. Amitesh Omar, Professor and Head of the Department, Space, IIT Kanpur. Sir, your distinguished contributions to research and academia greatly strengthen India's scientific ecosystem. Your presence today underscores our shared commitment to an educational environment grounded in inquiry, discovery, and innovation. We owe our deep appreciation to our respected chairperson, ma'am, Srimati Manorma Govindhariji Singhania, whose vision and unwavering commitment to academic excellence and holistic development of the students guides us in all the endeavors at Sir Padampat Singhania Education Center. Under her leadership, the school has blossomed into a center of learning that beautifully blends tradition with forward-looking tradition and innovation. My heartfelt thanks to our Vice Chairman, Sir, Shri Abhishek Singhania ji, Vice Chairperson, ma'am, Srimati Varsha ji Singhania, Vice Chairman Director, Sir, Mr. Parthokar, for their strategic insight, constant leadership, and continued support in every academic and infrastructural advancement of the school. The implementation of a skill-based education at Sir Padampat Singhania Education Center long before National Education Policy 2020 is a testament to the management's foresight and commitment to nurturing future-ready learners. This event resonates deeply with the enduring values of the JK organization, a legacy built on nation building, educational empowerment, industrial progress, and social responsibility. The organization's philosophy that education must equip individuals to contribute meaningfully to society is reflected in every initiative that happens at Sir Padampat Singhania Education Center. The establishment of the Astronomy Lab in the Sri Govindhari Singhania Center of Advanced Learning, comprising robotics, AR/VR, additive manufacturing, Vedic mathematics, psychology, music, art and sculpture laboratories, it strengthens our commitment to prepare students for future-oriented pathways in science, technology, innovation, and research. These academic assets honor the visionary idols of our founder chairman, Shri Govindhari Singhania ji, whose emphasis on knowledge, advancement, and skill development contributes to illuminate till date and keeps the mission upgraded. As we celebrate the scientific progress today, it is also a proud moment to acknowledge another milestone in our journey. Sir Padampat Singhania Education Center has been ranked the #1 day school in India and stands among the top 12 Ivy League day schools in the prestigious Education World India School Ranking 2025-26. This national recognition is not just a ranking, it is a reflection of the collective dedication of our management, parents, faculty, students, alumni, and every stakeholder who believes in the mission of the school. Together, we've created an institution that inspires excellence and stands as a beacon of quality education in the country. To our parents, thank you for your trust and your partnership. To our students, may you ignite the desire to explore, question, innovate, and dream without boundaries. To the teachers and staff at SPSEC, my sincere gratitude for your meticulous planning, seamless arrangements, and tireless commitments in all the endeavors and all the events that make it a great success. In closing, I reiterate our profound gratitude to Professor Somnath for honoring us with his presence and offering insights that will continue to inspire the academic community. Sir, your words will remain with our students as a guiding force. You have shown India and the students of SPSEC that the sky is not the limit, it is only the beginning. Thank you all. Jai Hind.
Thank you so much, ma'am. And with this, we come to the end of today's session. Thank you so much for coming. You need to ask one question. Ma'am, do we have time for that? Okay, since you're so keen, we will entertain. Thank you.
Good afternoon, sir. I am really nervous. I don't know. I only want to ask one thing from you. We always talk about success. We always talk about what we have achieved. Sir, we are here interacting with you. I don't know anytime in future I'll be able to have this session or not. My only question to you is, how do you stand those challenges? How do you overcome those things? How do you overcome the failure? And what is your motivational advice to the young learners sitting here?
Okay, thank you for that question. But then, because time is not much, so I would like to limit my response in a very simple way. See, one of the important things you need to realize that in any domain, like complex domain like that, what you work here, failure is a possibility. Okay, so anytime you can fail. But then what will you do if something is going to fail when you want to venture into that domain, knowing very well there is a possibility of the failure? Will you venture into it or not venture into it? It's a question of choice that you have to make. And all associated risks are there. So, like if you want to climb Himalayas, there is a possibility that you may not ever reach there. You may die on the way. But still, hundreds and thousands of people still climb Himalayas. Do you know that? Today, number of people who are dead and buried on the foothills of the Himalaya are hundreds, not one. Still people climb Himalayas because it's the excitement, the journey, the accomplishment that still lure us to reach there still. It is true in any endeavor in life, there is a possibility of the failure, risks, challenges. It's all there, part of it. But then it has to be taken. And that's how humanity grows. For domains like us in space, unless you venture into it and then face the challenges head on, you are not going to make success. So for us in ISRO, I think we have faced enough of challenges. We had failures. When I joined ISRO, ISRO was not like this. You people would have even shouted at me. In 1980, when I joined, my rockets were all failing. ISRO was never in the headlines. ISRO was in the headlines only because of one reason. All the rockets that ISRO launches go to the sea. And we were called Always Sea Launching Vehicle, ASLV. Our rocket was called ASLV, Always Sea Launching Vehicle. That's the time I joined ISRO. So we have to turn the wheel to success. It required a lot of hard work, it required a lot of learning, a lot of motivation inside. And once you tasted success, you know how to sustain it. And once PSLV was a successful rocket first time, I think there was no looking back. And we realized that the whole success came because we worked very hard. There was lack of knowledge. The knowledge gap was built over a period of time in collaboration with the various institutions. And I don't want to go into all of that. But there were wonderful leaders in the organization. And for any institution or any organization to become successful, you need great leaders. Leadership which actually is self-motivated, who actually see the purpose at some far ahead. But you know there are a lot of issues nearby. The the whole purpose of the organization ISRO has been to develop leaders. And I came out of that process. When I joined ISRO, I was not a great leader. But going through that journey, I can tell you that I can now handle complex problems or complex projects without getting ever worried or tensed. Today in launches, I don't get tensed also. I have watched at least 80 launches in my life, 80 launches sitting in the control room. Never ever I've gone out and seen a launch myself. Only after retirement, I have gone out and seen a launch myself. So I want to tell you that whoever wants to build great institutions have to put a lot of effort, has to face challenges, and that has to be faced head on. There is no shortcut to it. No shortcut to it. Thank you.
Thank you, sir.
Thank you very much, sir. With this, we'll conclude today's session, and again with a resounding applause, let's appreciate sir's time. Thank you.